Hello everybody. In this video, we are going to answer question number 14 from June 2019 Unit 2 exam, which is a linkage question, or more commonly known as a star question or a 6-marker. Let's start the question. In 1921, Albert Einstein was awarded the Nobel Prize for Physics for his discovery of the law of photoelectric effect. To explain this effect, Einstein proposed that electromagnetic radiation should be modeled as a particle rather than as a wave. Explain why, when considering the photoelectric effect, treating electromagnetic radiation as a particle is a more successful model than treating electromagnetic radiation as a wave. Now, since this is a linkage question, we will be focusing upon what points to include or the indicative content that needs to be seen in the answer. Secondly, we will be focusing upon how to structure and organize these points to score full 6 marks. So let's get started. So first of all, let's have a look at the command word used over here. The command word used over here, like many other 6 markers, is explain, which means whatever points you write here, you have to provide a reasoning for all those points. So we will focus upon the statement given after explain. Explain why, when considering the photoelectric effect, treating electromagnetic radiation as a particle is a more successful model than treating electromagnetic radiation as a wave. Now, our entire answer will be focused upon this complete statement. So if you simplify the statement, what does it mean? It basically means that we have to explain how photoelectric effect and its observations can be perfectly explained using the particle model of electromagnetic radiations rather than the wave model. So for that, you need to obviously recall and think of all the observations that were made as a result of the photoelectric effect. Now, when we are answering a linkage question or a 6-marker question, my first suggestion to the students is do not start writing or drafting your answer immediately after reading a question. This is a very common mistake made by students. They read the question and they start penning down their answers. This is the biggest mistake you can make. Why? Because, in a 6-marker, there are only 4 marks for the content or the points that you mention. Even if you have mentioned all 6 points, the maximum score you can get is a 4 out of 6. To score the whole 6 on 6, your answer needs to be structured appropriately in a logical and sequential way. And in order to write your answer in a logical and sequential way, you must first organize your thoughts. So what I recommend is first of all, just brainstorm, think about the points that you should be writing to answer this particular question, which should be contextual, and jot them down with a pencil, maybe somewhere around this space, which is below the answer space, somewhere over here perhaps. Or every paper has multiple blank pages. You can use one blank page, the one closest to this question, and jot down the points. Now, jotting down the points does not mean writing your answer twice. It means you just need to jot down briefly what points you think should be mentioned as an answer to this question. So let's first quickly think about what should we include in this answer. So I will read the question again to understand and break it down what the question wants me to answer. Explain why, when considering the photoelectric effect, treating electromagnetic radiation as a particle is a more successful model than treating electromagnetic radiation as a wave. So now basically it wants me to describe what were the observations of the photoelectric effect and then give a reason or an explanation of how each observation can be explained using a particle model rather than a wave model. So let's quickly recall the observations of the photoelectric effect. Number 1. The emission of electrons from the surface of a metal was only possible after a certain threshold frequency. For any frequency below the threshold frequency, no matter how high the intensity of the incident radiations was, there was no emission of electrons. That was observation number 1. And why did the wave theory fail to explain this? Because according to the wave theory, the greater the intensity of the radiations, the greater the energy provided to the electrons, and hence at any given frequency, emission of electrons should have happened, but that was not the case. So this is one observation which could not be explained using the wave theory. So immediately we will just jot this down. And how we jot this down, I'll just show you in a bit. Second observation, the kinetic energy possessed by the electrons emitted from the surface of the metal was dependent only upon the frequency of the radiations used and not upon the intensity of the radiations. Now again, linking it to the previous part, if intensity of radiations was a direct measure of the energy provided by the radiations, then the kinetic energy of the electrons should also have been dependent upon the intensity, but it was otherwise. The kinetic energy of the electrons was a function only of the frequency of the radiation, which means can this be explained using the particle model? Because according to the particle model, energy of a photon is equal to HF, E equals HF, which means energy of a photon is only dependent upon its frequency and not intensity. Number 3. The emission of electrons from the surface of the metal started all instantaneously, immediately, as soon as radiations were incident upon the metal surface, as long as the frequency was higher than the threshold frequency. Now, according to the wave model, emission of electrons should only happen once enough energy has been incident upon the metal surface, which should obviously take some time for the electrons to absorb enough energy. Number 4. The number of electrons emitted was dependent upon the intensity of radiations and not the frequency, whereas according to the wave model, it should have been dependent upon the frequency or the number of waves incident per second. Instead, it was dependent upon the intensity, which means how many photons were incident per unit time on the surface of the metal. Now, once you jot down these points, now you are going to write them down properly in the form of a structured answer. This is what I have jotted down, which you can see in green color right now. And if you write it down with when you write it down or when you jot it down with a pencil on a piece of paper on either the side corner or either below the answer space with a pencil with a light hand or on a blank page, and it will take you a maximum of a minute to think and jot down. I have shown these points within the answer space so that I could show it to you. In the final answer, you're not supposed to use numbering or bulleted points. You have to give your final answer in the form of a paragraph. Now, how you're going to structure this paragraph, I have written down 4 points over here, and I'm going to now structure them properly in a clear way using correct key terminologies according to the topic and in a way that each point is logically connected to the previous point. And this is what my final answer looks like, and I'm going to read it out now. According to the observations made, electrons were ejected from the surface of a metal only when the frequency of the incident radiations was above a threshold frequency. According to the wave model, the effect should have been triggered at any frequency provided the radiations had high enough intensity. As per the particle model, only photons with high enough energy could trigger the effect, and photon energy is given as E equals HF, where F is the frequency. Now, the reason I wrote this equation is, you will not see it in a marking scheme, but I always recommend my students, whenever giving any explanations in any form, in any kind of question, always give a supporting equation, a scientific equation which supports your statement. So how can we support the fact or the statement that energy of a photon is a function of its frequency? By using this equation. Okay, so all these points cover the first point in our brainstorming. Now, and we are writing it all as a paragraph, not bullet numbering them, not numbering them, or not putting them as separate points. Next we have here, the effect was instantaneous, but according to the wave model, the radiations should be incident upon the metal for long enough so the electrons gain enough energy to be emitted. As per the particle model, once the incident frequency was above the threshold value, the effect could be triggered instantaneously. Now you can notice a trend over here. I have mentioned an observation first, and then immediately followed by that, I have written how wave model fails to explain this observation and how particle model successfully explains the same observation. Next we have the maximum kinetic energy of the emitted electrons was found to be only a function of the frequency of the radiations. It should depend upon the intensity as per the wave model. Next, the number of electrons ejected was dependent upon the intensity of radiations. Intensity means number of incident photons per second. This is according to the particle model. As per the wave model, it should be dependent upon the frequency of radiation, which is number of waves per second. and that completes your entire answer. All the points that we have jotted down during our brainstorming 30 seconds or a minute, we have now organized them, structured them in a proper sequential way. So each observation is followed by how it can be explained successfully, particle model, and how the wave model fails to explain it. Now this kind of an answer is surely going to get a whole 6 on 6.